In the dark outskirts of our solar system, far from the warmth of the sun's life-giving rays, lies a world cloaked in ice and mystery. Saturn's moon Enceladus, a shimmering orb barely 500 kilometers across, silently orbits its massive parent, trapped in an eternal cosmic dance. To the casual observer, it might appear insignificant, a frozen sphere of ice and rock amid a sea of celestial bodies. But beneath its cold, brilliant surface, something extraordinary is unfolding. A story of heat and water, of chemistry and possibility. It is a story that challenges everything we think we know about where life can exist. For here, on this tiny, frozen moon, nature seems to be whispering secrets that could reshape humanity's search for life beyond Earth. Enceladus isn't just an icy satellite. It's a beacon of hope, a world that defies expectations, holding within its depths the tantalizing ingredients for habitability. Enceladus's surface is a dazzling expanse of gleaming ice, so reflective that it shines like a brilliant jewel in the darkness, outshining even Saturn's famous rings. Yet beneath this pristine exterior lies a hidden world, a vast ocean of liquid water trapped beneath kilometers of ice. Scientists estimate this ocean stretches globally, connecting the North and South poles in a liquid sea unlike anything else in the solar system. The existence of this subsurface ocean was first hypothesized decades ago, but it was NASA's Cassini spacecraft that provided the proof. Through multiple close flybys, Cassini detected plumes of water vapor and ice particles erupting from fissures near Enceladus's south pole, fractures aptly named tiger stripes. These jets reach hundreds of kilometers into space, carrying with them not only water but complex molecules, salts, and even tiny grains of rock. The very presence of these geysers tells us that Enceladus is geologically alive. It is warmed from the inside, heated by the gravitational pull of Saturn and neighboring moons, a process called tidal heating, which generates friction and internal heat. This energy source prevents the ocean from freezing solid, maintaining a stable environment where liquid water and rock interact. One of the most revolutionary discoveries Cassini made was the detection of molecular hydrogen within these plumes, a finding that offers a glimpse into the complex chemistry at work beneath the ice. On Earth, molecular hydrogen is produced when seawater interacts with volcanic rock at hydrothermal vents on the ocean floor. These vents host rich ecosystems, teeming with life that exists entirely independent of sunlight, relying instead on chemical energy. The implication is profound. If Enceladus has similar hydrothermal vents, the basic conditions necessary to sustain life might be present. Heat, water, energy, and the right chemical ingredients come together in a cosmic recipe that could nurture microbial life, or at least prebiotic chemistry, the very building blocks of life. Moreover, the ocean's salty composition, combined with the presence of organic molecules such as methane and carbon dioxide, suggests a dynamic environment where complex chemical reactions could occur. The interplay between water, heat, and rock creates a crucible for chemical evolution, a potential cradle for life that has fascinated scientists and dreamers alike. Despite the growing evidence for habitability, a critical question remained unanswered. Does Enceladus contain phosphorus? Phosphorus is a key element in the molecules that form the backbone of life on Earth. DNA, RNA, and ADP, the energy currency of cells. The outer solar system is typically depleted in phosphorus, and until recently, its presence on Enceladus was purely speculative. However, meticulous analysis of Cassini's plume data revealed phosphates embedded within the icy grains ejected from the moon. This discovery was groundbreaking. It meant that Enceladus's ocean contains all the essential chemical elements needed to support life as we know it. Finding phosphorus not only bolsters the argument for habitability, but also highlights the moon's remarkable chemical richness. The complex organic compounds detected hint at a prebiotic chemistry that might parallel early Earth's own primordial soup, a vast natural laboratory where life could emerge. The possibility that Enceladus could host life opens a doorway to one of humanity's greatest questions. Are we alone in the universe? If life exists here, it would represent a second genesis, an independent emergence of life beyond Earth. Such a discovery would revolutionize biology and our understanding of life's origins. It would suggest that life is not a unique phenomenon restricted to one planet, but a natural outcome of certain conditions recurring throughout the cosmos. Life could be common, distributed across countless worlds with subsurface oceans beneath icy shells, waiting patiently in the dark. This paradigm shift extends far beyond Enceladus. It implies that the search for life should focus not only on Earth-like planets, but also on icy moons with hidden oceans, Europa, Titan, Ganymede, and beyond. Each could harbor ecosystems thriving in alien seas, undetectable from afar, but no less profound. Though Cassini's data revolutionized our understanding, it was only the beginning. Future missions are poised to take the next steps, to move from hint to confirmation, from possibility to proof. NASA's proposed Enceladus Orbilander mission aims to orbit and land on the moon, sampling plume deposits directly and performing detailed analysis of surface and subsurface chemistry. Advanced instruments could search for biosignatures, markers of past or present life, and unravel the mysteries of Enceladus's internal ocean. More ambitious concepts envision robotic submarines melting through the ice to explore the ocean itself. Cryobots equipped with miniaturized laboratories could investigate the chemistry of alien waters, searching for microbial life forms or traces of biological activity. These missions, though technologically challenging and costly, promise to answer a question as old as human curiosity: what lies beneath the ice? Enceladus remains a silent enigma, a moon that whispers across the void. Its geysers send messages not in language, but in molecules, hints of a hidden world where life might flourish. The journey to understand Enceladus is a journey to understand ourselves, our origins, our place in the cosmos, and our future. For if life has arisen twice in our solar system, the universe may be teeming with living worlds, waiting to be discovered. In the frozen shadows of Saturn, Enceladus is alive, alive with possibility, alive with the promise of discovery. And as we listen to its quiet breath, we are reminded that sometimes the smallest worlds hold the greatest secrets.